In earlier videos, we looked at how models can be built up predictor by predictor, stringing betas together like a chain. In this video, we look at this in a bit more detail. We are going to do some manual calculations here. Now you don't need to do them by hand in practice. This is only to illustrate what the betas mean, how to interpret them, and how to explain them in plain English. By the end of the video, you should understand the difference between multiplicative and additive models. For multiplicative models in particular, you should understand, particularly when looking at the charts, that the beta is approximately the percentage impact of a case being at a particular level. You should also understand how a predictive model differs from the ANOVA and t-tests. In a nutshell, unless you run specialized tests, ANOVA and t-tests will simply tell you that, yes, there is a difference between male and female or young and old. A predictive model will tell you what that difference is, and how each predictor can be combined to make a prediction, or produce a modeled value for each specific case. The important points that we touched on in earlier videos were that the concept of a base level is important. The base level is a notional set of characteristics against which the model revolves. For each predictor, Preddle chooses the level with the highest sample size as the base level. The overarching base case can be thought of as a hypothetical record or case having the base level for all the predictors. For example, a female with 1 to 3 years of college and that is aged 30 years old, if each of these individual levels are base levels for various predictors. For each predictor, each beta was the modeled effect on the gambling problem score of deviating from the base level. For example, being male as opposed to the base level of female, or doing 4 years of college as opposed to the base level of 1 to 3 years of college. While for an additive model, we add the betas together like a string, for a multiplicative model, we can string them together as a percentage impact. Now we haven't discussed probability models yet, but they are effectively using a multiplicative model to model the odds, and then you, or Preddle in this case, converts that odds to a probability. Now in an additive model, you add the betas together like a string. The two key things to remember are that for linear variables, you first need to multiply the beta by whatever value the variable takes, and that you always need to include the intercept. I will explain what the intercept is after the following two examples, which are based on these beta parameters from an additive model. So how does this model tell us the gambling score for a particular individual who has rated their importance of faith as 2, has had 0 moves in the past 12 months, who attended up to 9th to 12th grade, and is female? All we do is pick up the relevant betas and add them together. Pick up the intercept first. Their importance of faith linear variable beta was 0.00458. So multiply this by their importance of faith score of 2 to give 0.00916. 0 moves has a beta of 0 because it's the base level. Recall that the betas for the base levels are always 0. 9th through 12th grade beta is also 0 because it's also the base level. And the female beta is also 0 because female is the base level. Then simply add 0.035 to 0.00916 plus 0 plus 0 plus 0 to give a modeled gambling score of 0.04416. Now as a second example, take a male with an importance of faith score of 4, 4 moves in the past year, and 4 years of college. Picking up the relevant betas in the same way, and remembering to multiply the linear variable beta by this individual's importance of faith score of 4 this time, gives a modeled gambling score of 0.06422. Now compared to the first example, you can see that the reasons this example has a higher modeled or predicted gambling score is because they had a higher importance of faith, had more moves, and was male. Their score was tempered back somewhat by having more years of college. So you may be wondering, what does this intercept represent? Why do we need it? Well, remember from the first example that most of the predictors were at the base level, so the betas were 0. Imagine if all the predictors were at the base levels, and the linear predictors had value 0. The intercept would be the only non-zero value left. You still need a predicted value for this person though. Therefore, the intercept is the modeled score for a case at the base level for all categorical factors and with a score of 0 for any linear variables. Now the multiplicative model works in exactly the same way, but with two differences. First of all, you put each beta term inside an exponent, and secondly, you then multiply them all together rather than adding them together. So here is an example using the earlier model we built. Here we've got a white male living in the south, largest amount lost of less than $100, one move, etc. Like with the additive model, we pick up the intercept first. This is negative 0.218. Then we wrap that in an exponent. For those that don't know, this means taking e to the power of negative 2.18. Now e is a special number in mathematics. It's similar to pi. Pi is roughly equal to 3.14. E is roughly equal to 2.71. But rather than remembering this, it's easier to just use the exp function, or the e to the power of x button on your calculator. So e to the power of negative 2.18 is 0.113. The beta for south is 0, so e to the power of 0 is 1. Similarly, the beta for white is 0. The beta for not gambled in the past year is 0.396, which gives 1.486, and so on for the largest amount lost, 1 through 3 years of college, male, 18 to 29 years old. Now the effects of legal gambling is a bit different because we fit it as a spline, if you recall. We fit this as a straight line up to 3, then another straight line above 3. The levels down here make use of min and max functions. The score for this individual is 2. Now the minimum of 2 and 3 is 2, and the maximum of 2 minus 3 and 0 is 0, because 2 minus 3 is minus 1. For each of these spline terms, you multiply the value by the beta and put it inside an exponent. The importance of faith and why not moral predictors are both linear variables, so we multiply these by the beta and put them inside an exponent in the same way. Then once we've got all these numbers, because it's a multiplicative model, we just multiply them all together to get a modeled gambling score of 0.1225. Anything at the base level has a beta of 0. Exponentiating this gives a multiplier of 1. Any positive beta gives a multiplier of greater than 1, and any negative beta gives a multiplier of less than 1. The key thing to remember is that the beta itself is close to the percentage impact of the multiplier. Take male with a beta of 0.0708. When eyeballing the charts during the modeling process and looking at the gender predictor, you can think of the effect of being male as increasing the gambling score by about 7%. When we exponentiate it here, the exact multiplier is 1.073, which is a 7.3% increase on the gambling score compared to individuals at the base level for this predictor. Now the base level is female. Similarly, for 1 to 3 years of college, the beta is negative 0.415. So you can think of this when you're eyeballing the charts as a negative 42% impact. When we work through the maths, we find the actual multiplier is 0.66, which is actually a negative 34% impact. Thinking in this way provides useful approximations when looking at the charts and interpreting the raw betas as percentage impacts without having to pull out your calculator each time. Rather than just fitting an additive or multiplicative model, there is a third possibility, that of modeling a probability. If in the Preddle workspace wizard you said you were modeling a probability, the settings would then include a logit link function and a binomial error distribution. Behind the scenes, Preddle isn't modeling probability directly, it's multiplicatively combining the betas to model the odds of a success for that trial, and then converting from odds to probability. Now, odds is just a different way to express a probability. The odds notation originated hundreds of years ago in gambling circles. The odds of something occurring is the probability of it occurring divided by the probability of it not occurring. For example, the odds of someone having depression divided by the probability of them not having depression. So if someone has a 60% chance of having depression, then this means there is a 3 in 5 chance of them having it and a 2 in 5 chance of them not having it. So out of 5 such people, 3 will have it and 2 won't. The odds of someone having it then is 3 to 2, not 3 to 5. This is the difference between odds and probability. As the probability of something occurring approaches 1, the odds approaches infinity. If the probability of something occurring is 99%, then the odds is 99 to 1. So this is the formula for converting probability to odds. This is the formula for converting odds to probability. For example, let's say you've got odds of 3.45. This is equivalent to a probability of 77.5%. If you chose a probability model, Preddle models the odds of an event occurring, such as having depression, using a multiplicative model. Then you can go through the same process we went through on the last slide, including putting each term inside an exponent and multiplying them all together to arrive at a modelled odds of, say, 3.45. Then you can use this formula to convert that modelled odds to a modelled probability of 77.5%. Now, a probability ranges from 0 to 1, whereas odds ranges from 0 to infinity. Preddle is designed to be graphical and intuitive, rather than mathematical, so it may not be essential to know all the stuff we just covered to build models and conduct statistical tests. You can refer back to this video if you ever do need to understand or interpret what it's doing. But in a couple of videos down the list, we get some scoring code from Preddle that will literally take all the beta parameters and compute the modelled values for all cases at once, so you never have to go through this by hand like we just did in this video.